All right, I'm going to be going over the weather test study guide. Obviously, this is not really so much used for a study guide because the test and the study guide and all that is not graded, but it's just what I had from last year and it was easier than making new stuff. So, things you need to really understand over this weather unit. First thing is the difference between weather and climate. So, weather is something that's constantly changing, changing by the hour, changing by the day, and it is the conditions of the atmosphere at that time and place. So it can be storms, it can be, is it raining outside right now? What's the clouds like? What is the um, dew point outside, winds, all of that is weather. The climate, however, is the average weather pattern over a region for a pretty long extended period of time. So the climate is slightly changing, as we've been talking about with global warming, but generally it's the same kind of patterns as normal predicted for that season. These are the different instruments that meteorologists use to predict the weather, make forecasts. So we have an anemometer, which is this picture here, and that's moving, showing me the wind speed. The wind vane is telling me which direction the wind is blowing. A rain gauge or a snow gauge tells me how much precipitation has happened. A thermometer tells me my air temperature. A barometer tells me the air pressure. And the hygrometer tells me the humidity levels. So the big one that's probably new is barometer, anemometer, and hygrometer. Think H, humidity, hygrometer. We know the air pressure is really huge on predicting your lows and your high pressure zones, and that tells us a lot about weather. And then wind speeds in the anemometer to tell me which way the winds are blowing. Then we have the different types of clouds. So water vapor is the air that rises, cools, and condenses into a speck of dust or another particle. Clouds form when these water droplets come together and are visible in the sky, and it will eventually precipitate with either rain, snow, sleet, or hail when the droplets become too heavy and they fall down to Earth's surface. So these are the main types of clouds. So we have the big, white, fluffy, pretty clouds. That is your cumulus clouds. When you see those clouds, it's going to be pretty good, fair weather. If you see stratus clouds, which is what it is today outside, those are lower to the ground, light, kind of just looks like a blanket covering the sky, lots of layers of clouds, and it's just the overcast. So just gloomy, cloudy day. Might rain a little bit, might snow a little bit, might be a little foggy outside, because there is precipitation in the air, but it's just kind of a cloudy day. Cirrus. Those are the ones really high up in the sky, and those are the very thin, wispy, feather-like, kind of might look like the pollution out of an airplane even sometimes is what it looks like. It's just like stringy. That's going to be some pretty good weather, fair weather, but the weather will be changing in the next 24 hours because basically clouds are starting to form. Cumulonimbus. So cumulo, remember that means it's accumulating, putting it together. It's big, fluffy. Nimbus is storms. So this is the tall clouds that kind of stack and build, and as they're getting bigger and bigger, that's later going to probably be thunderstorms and severe weather clouds. Nimbostratus, again, nimbo means storms, stratus is layers. So that's when it looks like it is now, but it gets darker outside. The blanket of clouds, and it's just going to rain a whole bunch or snow a whole bunch later. So steady showers or rain. And then we have fog, which is when the stratus clouds are touching the ground and very hard to see visibility wise. There's just a lot of moisture in there. Different types of precipitation. So we know rain is if it's not freezing and it's just water falling out of the sky. Snow, it has to be colder outside, but it can't be really completely freezing because that would just be sleet or freezing rain or hail. This is ice crystals. Sleet is more of a pellet. What's happening is it's snow that's falling and then it gets warmer as it's falling from the sky and it's melting, but then it's refreezing again before it hits the ground. So it's kind of, we know that the layers of the atmosphere has different temperatures. And so as it's falling down, our temperatures are changing and then changing again. And that is when sleet happens. Freezing rain is just regular rain, but the second it touches the Earth's surface, it's freezing. So it's really cold down here, and it's going to turn into ice on the roads. Hail is basically just a big ball of ice. It can be anywhere from little pellets to golf ball, baseball size. It's formed always in the cumulonimbus clouds during thunderstorms and updrafts of winds. So then we have air pressure. So air pressure is the weight or force of the atmosphere pushing down on something. Altitude, we didn't talk about this a ton in class, but this is, you have different altitudes, the different distances above or below sea level. Obviously, the higher you are up, the higher your altitude, the air pressure decreases. If the altitude decreases, the air pressure increases. So we've talked about air pressure with, like, if you're in the mountains or if you're really deep underwater. If you're swimming, like, your ears will pop. If you're in a plane, your ears will pop. There's like extreme pressure in the different layers of the ocean. So when that altitude changes, that can change your air pressure a lot. When there's a difference in air pressure and you're not underwater, it's going to change the wind. The larger the difference in air pressure, the faster the winds will blow. Air always likes to move from high pressure to low pressure areas. That's just how its patterns go. So we know a high pressure system uses the big H. Our winds are blowing clockwise, which is important for us to know. The air is heavy and sinks, and if it's high pressure system, it's a nice day outside. It's cool, clear, dry air. If it's a low pressure system, however, our winds are going counterclockwise. We see the red, meaning more severe. It's going to be precipitation. It might just rain, snow, but it could also storm pretty badly, depending on the fronts that are around that low pressure system. The air is light and rises, which causes evaporation and condensation to happen pretty quickly. And when all that moisture evaporates and turns into clouds, then it's going to obviously rain or snow. Air masses. So air mass is a large body of air with the same exact temperature and humidity. When there's two air masses that meet, it's called a front. A front typically is when two different air masses meet, though it's not the same, because if the same air masses meet, it just turns into a bigger air mass. If there is a front, most of the time there is precipitation. So warm fronts, we use the little half sun symbols, and it's red. Warm front, there might be some warmer temperatures because the warm air is what's rising and what is kind of winning the situation. So the warm air is over here. It's going to meet the cold air and the warm air will rise. Warm air always has to get to the top. So in this case, it just kind of goes over the cold air. So it's not so sudden because it's just slowly rising. The warm air is winning in this situation, so it's going to rain a little bit or snow a little bit, but it's not going to be severe. A cold front, however, is when the cold air is pushing the warm air, and the cold air is winning, but it's going to push up that warm air a lot quicker. And since it's happening faster, that's going to cause really quick condensation and evaporation happen, and that's going to cause your severe storms. So all of a sudden, it's going to change. It's going to be cooler outside, and most time you can tell, like, when it's going to storm really bad in the summer, because the temperature changes, it drops really quick, and you can just tell that the warm air is just magically gone. It's all higher up in the sky. We can't feel it as much, and the thunderstorms, tornadoes, severe weather is going to happen. Stationary fronts is where they meet, but they really don't move. They kind of just slide past each other or just kind of bop back and forth, and they're not trying. It's like they're not battling to try to see who wins. So that is where you have the cold and warm front mix symbol. It might be really cloudy for a few days, or it might rain still for a few days, but it's just kind of gonna hover there, staying in that spot. Occluded front is the purple symbol. It's still the half moons and like the shark teeth, but it's purple and it's all facing one way. And remember, occluded, cold, and warm fronts, the way that the teeth or the circles are pointing is the direction the wind is moving. Stationary, it's going to show on both sides because it's not really moving into a certain direction. It's just kind of staying there. So an occluded front is where the warm air gets caught between two cold air masses. And the warm air has to rise in between the two. So you have cold over here, and the warm's in the middle, kind of getting squeezed up to the top. It's going to be very windy and lots of rain for those. So a current or a stream is when wind or air flows into a narrow band. These are the four main types of wind streams that we have. So we have a jet stream. A jet stream is very fast. Think of it being a jet. Typically, this goes from west to east. We've already talked about this in class. Our winds always go the same general direction. So our storms currently have been moving basically the same direction all the time. We don't have storms that come from the east and go to the west hardly ever. Like, that just isn't a thing because the wind directions are in a certain stream. So the jet stream moves things from west to east in the U.S. Anything north of that jet stream is going to be colder weather. Anything south is going to be warmer weather. We know this. The Gulf Stream, however, this is a warm ocean current in the Atlantic that flows from the north equator along the eastern coast. So we don't really see this as much. Jet stream is our life. We see this all the time. The Gulf Stream is all the Gulf Coast. Keeps the eastern coast mild and warm. So this is going to be like all of your coastline on the east side of the United States. El Nino and La Nina. This is happening where the cooling and warming of the ocean waters, basically. So the Pacific Ocean, when it gets unusually warm, that's when El Nino is happening. And if it's getting really cool in the Pacific Ocean, that's when La Nina is happening. That's going to cause severe storms. These storms, a lot of times hurricanes are formed because of these jet streams, and can cause either us to have very dry. If it's really cool, it might not evaporate enough and we won't get enough rain for a while, or it can do the opposite, and these can have lots and lots and lots of rain for a really long time. So those are the streams. Don't need to worry about that too much. On a water cycle, we need to be able to understand and label a map. So we know that transpiration is when the water is evaporating off of plants. After it transpires, it has to condensate into a cloud. Then the cloud precipitates, and it then runs off, and it can run off on both of these here. And after it runs off, it's sitting and accumulating. So this is accumulation. That accumulated water will evaporate, condensate into clouds, and then precipitate. So it's just the same pattern. Then we have some questions about storms. We didn't get into storms a ton because I wanted to push that project to the end of the year. But you guys have been reading about it in your textbooks, so you should be able to know generally about this stuff. So what kind of damage could a drought cause? Mainly it's going to cause crop damage, which we know because we live in Iowa. You might have soil depletion, or the plants are dying, so the soil isn't getting the nutrients it needs. The soil is going to be able to blow around a lot more because there's nothing protecting it on top, so that causes dust storms, the ground to crack. We know what droughts are. If there is a flood, what could happen? So hurricanes and tsunamis obviously cause floods from the oceans, and just tons of water that it's raining also during all of those. The other big thing is excessive rain in a low area. So that could be like sometimes a gravel road or a certain area in town might flood all the time every time it rains a whole bunch just because it's lower and the water just filters and drains there. Another thing is when it rains a ton, a lot of times the rivers get overflowed. And so when the rivers flood and the fields are flooding, the rivers are flooding, that can cause severe problems. What kind of damage can a hurricane cause? Obviously, houses are destroyed. Some major flooding. Sometimes the marine animals get relocated, so you might find a dolphin in the middle of a town, or you might find alligator. Like different things have been moved. Lots of debris is now left in the water, and that turns into water pollution, whether it's chemicals or it's the actual parts of houses or parts of buildings. Lots of debris is formed. What time of the year do tornadoes and hurricanes occur most frequently? So tornadoes is late spring and summer mainly, and hurricanes is summer and beginning of fall. Describe the weather during high pressure systems. Well, during high pressure, it's very nice outside, clear, fair skies. If it's a low pressure, however, there's going to definitely be some sort of precipitation and maybe some storms. 3 things that must happen in order for it to be a blizzard. So a blizzard, it doesn't even necessarily have to be snowing, but either it's blowing around a whole bunch or it could be snowing, but you're going to have very low visibility. It's going to be hard to be able to see outside. It has to happen for over 3 hours for them to classify it as a blizzard, and the winds have to be at least 35 miles per hour. Mainly, it's just the blowing of snow, and it's cold outside. Where do earthquakes happen? So, in the United States, it's typically on the coast, but earthquakes happen wherever your plate tectonics plates are. So, we will get into talking about Pangea and plate tectonics a little bit more when we get to the rock cycle. But we have our crust and it's broken into big pieces, and where those pieces are, the plates move because there's magma and lava underneath. And so when those plates move and slide, they can create mountains, they can create earthquakes and tsunamis, or they can turn into like valleys. So it's where the plate tectonics really are. How do they measure and classify these storms? So tornadoes, they use an EF scale, and that's where we categorize them as an F1, an F2, F3, F4, F5. That is, we rate them after it's happened. So it just basically depends on how much damage has happened in that area that it's hit, and that's how we classify what kind of tornado it was. But that's after the fact. Tornadoes we cannot like predict really super ahead of time. It's more of watching our radars, and then you see kind of where way it's going, and you just wait until you see funnel clouds basically, and someone calls it in. Earthquakes, they use a Richter scale, so it kind of looks like a lie detector test. And so as it's happening, the little pencil machine thing will just move across the page, and depending on how extreme the movements are, depends on how high of an earthquake they call it. But that's happening again during. They can't predict earthquakes. Hurricanes, they can predict, and they're able to see them developing over a few days. They use a Saffir-Simpson hurricane scale, so they have category 1 through category 5, and a lot of times they can predict what category of hurricane it is before it hits, and then it obviously dies out as it hits land. So they're looking at the wind speeds and how fast the winds are blowing and the size of how large the hurricane is or how big the eye is, and that's how they're determining what category of hurricane it is. But that is all the notes for the weather test. If you have questions, let me know, but you'll be able to use this to take the test tomorrow, and you can also go back and use your actual textbook as well. But hopefully, for the most part, we had covered all this in class, a little bit more with the reading, and we'll be moving away from the weather unit when we get back. We might finish with our forecasting project towards the end of the year if we have time. All right, thanks, guys.